Here are our keywords we're going to be using in this lesson. Here's the specification, and you can see we're currently on algorithms part F. Standard algorithms, and we're looking at these sorts, the first one being the bubble sort. Today we're going to be looking at the merge sort. First of all, watch the video to remind yourself how a merge sort works. Now this uses a divide and conquer approach. This is splitting the data in half. It makes it a lot easier and a lot more efficient because it only has to look at certain halves of data. So it successively divides the lists in halves until it's left with individual items. Then it merges them back together one at a time. Here's an abstracted view of a merge sort algorithm. At the top you can see our list. It splits it into two. Notice how that it can't split it perfectly into two lists, so we have a 4 and a 3. We then split each of those sublists into more sublists, so then they're in twos, and then finally on their own. What we then do is start merging them back together. So, the first two, 38 and 27, we merge into a small list. We then look at 3 and 43, and they're put in correct order, 9 and 82, and 10 is left on its own. The more complicated part now comes comparing the items in the list. So we compare 3, and we compare that to the first item in the other list, so 27 versus 3. We remove 3 from the list and put it into a new list because it's the smallest item, leaving 43 on its own. We then compare 27 to 43 and figure out that 27 is the smallest, then 38 to 43, figure out 38 is the smallest, and then place 43 at the end of the list. We do the same on the other side and then combine the lists together. Here is another view of our sorting algorithm. This time we've got 8 items. We realise they're all individual items and split them into different lists. So first of all, we divide and conquer it and split it into half and then into twos. Now you've got a set of pairs, each of those items is now compared. So you've got the red and the green, for example, here. Now because you've sorted those pairs already, the reds have been sorted, so 2 comes first and 6 comes second, you know that the smallest item in each of the pairs is first. So we compare those two items. So we compare 2 to 1, and we know that 1 is the smallest. So we remove 1 and we place it in a new set of 4 items. We then look at the smallest number from the next set. So we've still got 2 left in the reds, that would be the 2, and the one remaining one from the green, which is the 8. We compare those, and the 2 is the smallest, so we move that into order. We then compare the 6 and the 8, the last 2 which are left, the 6, and then the 8 should follow. We do the same with the next set of pairs. Here you can see the same thing has happened to the next set of pairs. We now do the same process as we did before last time, but this time we use those sets of 4. So we split the data and we start comparing them all the way through until we've got them in order. Working in pairs, I now want you to see how far you can get at writing pseudocode. Let's have a look at the cards to help. Here's the start of my pseudocode. I started with a list. What do I have to do? Define the list, create a function, create a new blank list, create the length of the dataset, find the midpoint of the list, create 2 new variables, 1 list from each half of the array. I'm then going to recursively call the procedure until I've got individual items. So I'm going to need some kind of check in there to check if the length of the list is larger than 1. We're then going to start creating a loop. It's probably a while loop, which is going to check and compare the values. Here is an example of my pseudocode for the list. You can use this pseudocode to create your own program in Trinket. Now complete the exam questions, mark them and make improvements.